Hello, and thank you for attending the Michigan State Design Day ME412 Final Project Competition. We are Team Jnj. My name is Joe Casuccio, and my teammates are
Jeff McCaig
and Nick Hansen.
The objective of this project was to model, build, and validate a vortex tube design. The vortex tube works by injecting pressurized air into a pressure chamber. This air then moves down a tube in a swirling motion, with the hot air swirling down the outside of the tube and the cold air passing in the opposite direction on the inside of the swirling hot air. This process allows for the vortex tube to act as a heat exchanger, thus resulting in hot air escaping from one end of the tube through a nozzle and the other end releasing cold air through a separate nozzle. The goal of this vortex tube design was to maximize the temperature difference between the hot end and the cold end, without a design that can accurately be mathematically modeled while minimizing the cost of manufacturing the vortex tube.
The design model for our pressurized swirl chamber is displayed here. The air inlet provides compressed air at 100 psi to the swirl chamber. The air inlet is angled at 10 degrees in order to promote the motion of the compressed air down the length of the vortex tube. The air inlet is also positioned tangentially to the inner cylindrical wall of the pressure chamber. This design induces the swirl in the pressure chamber. As you can see, when the swirl is induced and the hot air travels on the outside walls of the vortex tube while the cold air travels inside the swirling hot air. This creates the necessary conditions for the heat exchanging process.
First, in order to fabricate the hot end, a nozzle in the shape of a cone was created and inserted into the PVC piping that is our vortex tube. The depth of the penetration into the vortex tube by the cone-shaped nozzle can be adjusted using the adjusting screw. This design allows us to vary the hot air nozzle outlet diameter in order to produce the maximum temperature difference. In order to create the swirling chamber and the cold end outlet, a single piece of aluminum was machined to have the air inlet be tangential to the inner cylinder wall of the swirl chamber in order to induce the swirl within the vortex tube. The cold end outlet was then drilled out of the compression chamber at a small diameter in order to only let cold air pass through and not release any of the hot air swirling on the inner walls of the vortex tube.
After completing the design and building the vortex tube prototype, a temperature difference of 11 degrees Celsius was seen between the hot and cold end outlets. The overall cost of the vortex tube design was about $5.50, making this design a cheap yet effective vortex tube. On behalf of J&J, thank you for your time.